Okay, in this video we're going to be taking a look at a product to sum formula and how to prove it. First, just a little bit about these formulas. They are formulas that take a trig function where you have two different angles. For example, here sine alpha times sine beta. It allows us to transform that into an expression where instead of having a product of functions, we have a sum of functions. Now these identities like this, these product to sum formulas, are useful when you get into calculus and you need to take a product and rewrite it into a sum. Because in calculus, one of the things you do is called integration. And integration with something in the form sine alpha sine beta is very difficult. But sometimes when it's written as a sum, we're still able then to work the problem out. Now to prove this is pretty easy. We focus on the more complicated side, as usual with identities. And these formulas were probably originally found because people were taking these angle sum and difference formulas for identities, or for cosine in this example, or for sine in another example, and they were messing around with them and seeing what would happen. And here it turns out if we take that side and we just now invoke our cosine of a sum and difference, we'll get, of course, cosine alpha minus beta is cosine alpha, cosine beta, plus sine alpha, sine beta, and then minus the whole quantity, and then we write down the formula for cosine of a sum of two angles. And once we've got this far, it really is pretty straightforward now, because as we distribute, so first part's still the same, and then distributing -3, that becomes minus cosine alpha cosine beta plus sine alpha sine beta. And now hopefully it's pretty clear to see that your cosine terms are going to disappear, leaving us with 1/2 of, well, we have a sine alpha sine beta and a sine alpha sine beta, so of course we have two of those. And of course take 1/2 of 2 and you just get 1. And so we have sine alpha and sine of beta. And that's just an example of really, again, how quick and easy it is to actually prove one of these identities if you know the angle sum and difference identities for the cosine.